All right, so we might go up and down with the lights, but the first part of my talk is trying to impress you with my ability to make novel video games. All right, and so I promise we'll turn the lights up so you can see my face in a minute. Those of you watching on TV, I've been chatting with everyone in the room for a minute, so they know who I am. We are going to watch a couple little videos, and anyway, I'm a scientist that started making games. I wanted to make games so that everybody would have a gut level understanding of proteins and cells. Everyone's got something they're attracted to that they study. Some of you garden and you know everything about, blue roses. And if you wanted to explain blue roses to me, it would be complicated because I don't know all the stuff. And so this is my way of explaining the stuff I see and that I enjoy seeing. Okay, so this is the game that I made. It came out in 2013. Moelcular Games from a company. Bacteria, real bacteria, Staphylococcus, Streptococcus. That's my ship, that's basically a cell. And your nanobot is letting you see through the nanobot, or the microbot view screen. That's a neutrophil. Those are receptors. And those are E. coli. That's really exactly how E. coli looks.
As well.
You are?
Yeah. So.
Okay. Hold on a sec. What am I going to do next? Yeah. Okay. Well, so what I do is try to get scientists and people together to make games. And so one of the classes I was teaching at MICA in the spring every year is science game development. And it's really, the secret I want you all to know is that science game development is just like any other game development, right? You have lore in your game. We all have things we need to adhere to. You can't just throw out your lore because you can't figure out how to make the game work with it, right? You're writing a story, you can't just throw out the lore. And so, even though this is a science game talk, it's really going to be applicable to everybody's development. Okay, so this video that I'm going to show you next is a video that students made with a scientist named Alan Place at the IMET. IMET is on the bay, what do we call that, the Inner Harbor?
Downtown.
Yes, downtown. It's right next to the aquarium, and you might notice it. It's a big white tent. It's Institute for Marine Engineering and Technology, Environment and Technology. Yeah. So they study algae, and so the core of how I try to teach and the core of how I try to make games is to make the learning part of the mechanic. So I'll go into the details later, but you remember what you do. You remember what you need to do to win. That's what you remember. That gives you the feeling of the game, and it also teaches you. Okay, and so when we made the algae game, we wanted to preserve as much of the actual life of the algae as possible. So in the algae game, all algae do is eat other algae. Like these poor little single-celled organisms in the ocean, they eat each other. It's crazy. There's no camaraderie at all. And so you need to find the right algae to eat, and the other algae are trying to eat you. And so we need to tell the player who you're trying to eat and who's trying to eat you. And And the way to eat another algae is you have to get close enough, long enough to form a connection between your proteins and their proteins. All those things you saw in my cells, we don't show them to you in here, but you need to get close enough to somebody for 3 seconds. We made it so you can eat them. But what it does is it's this brand new mechanic, totally crazy, but it makes you feel like an algae out in this giant ocean. You have to find this tiny little thing that is your food source, and then you have to catch it. Okay, this is a video of it. Let's see if you can get the feeling from a video. The students did a wonderful job with the art and the coding.
What was this created at?
Unity. This is Unity. Yeah. So it's our very helpful UI. It was also done in 15 weeks. And you have 3 minutes before you run out of energy in your body. And this is you. That is a beautiful algae. The other ones are supposed to be beautiful, but the artist, the student, learned how to animate while we were making the game, and didn't have time to implement. They did the animation, but didn't get them into the game. So these other things are algae too. They're the rough draft.
Do they really only live for 3 minutes before they run out of energy?
Good question. So in this sim, a minute is a day.
Oh, so it's like sped up.
Yeah. We wanted to come up with a time that would work, a time scale. So you can play the game, by the way, if you want. I have it on this computer. It's great. It's also an itch. It is called The Harbor is My Home. And the student who made all the litter is the student that named the game the sweet, emotional name, The Harbor is My Home. It's springtime, so they drew the cherry blossom leaves in the water. And I think it's really hard. You only get to use 2 arrow keys to drive here out. Look, we ate it. and our energy went up. It's hard without the music. Okay, it's going to go on and on like this until we lose. So I'm going to stop it. Okay, I've got one more video that I hope I get to show you. Let's see if I can make it happen. This is another game mechanic. I've got 2 more game mechanics. Let's see. So this is supposed to be a VR game where you're on the surface of a cell. So those receptors we saw on the outside of a cell. I wanted to give you the feeling for how chaotic it is on the surface and that everything's moving. We don't ever see a picture of a cell that looks complicated. They always look shiny, don't they?
Yeah.
Yeah, smooth, bald, but they are not. This is the action center. Like, this is where you know if you're starving or not. If you've got no ATP bouncing on your ATP, if you've got no glucose, glucose is coming, not ATP. And so it's plays like Star Fox. You have to locate the bacteria. So you're being pulled towards the bacteria, but if you steer and avoid these giant bumper car things, you will get there faster. So it's called Nano Crasher, and it's teaching you that proteins move randomly, and it's also eventually going to teach you that they bind to each other randomly, and so you'll see 2 coming together, and if they look like they're going to bind, you want to go around them, because when they bind, they conserve momentum, and they won't bounce off of each other. They'll stick right in front of you, and you have to try to. So you eventually, you're trying to get to that center right there, because the computer, your onboard nano computer, is telling you that thing up there is an E. coli. E. coli is like, it goes on forever. It's so much wider than you are. You're a protein, so you can't see past it. And so now you have to shoot it. And the computer has told you where the weak spots are, and you have to try to shoot it. And of course, the proteins make it difficult. Yeah. And we used a volcano asset to show you that the E. coli is under pressure. When you cut a hole in it, all its guts spurt out. And if you cut enough holes, it dies. So this was an Android cardboard game. keep it till we win, because it's got a definite, we won. Yeah, there we go. Ta-da, we killed the bacteria. Okay, so would somebody mind turning on the lights again? Thank you. What's your name, lights?
Fiona.
Fiamma?
Yeah.
Fiona with an N or an M?
With an M.
Like Melanie. All right, Fiamma, nice to meet you. What? Melanie has one. Okay, so, awesome. So, what we did was we decided what our learning objectives were going to be. And a learning objective is a user experience goal. Have you heard of the term user experience goal? Anybody in here? User experience goal? Okay, good. So I'm going to take an account of what you guys know and experience you've had making games, and then I'll be able to talk to you about it. I want this to be much more interactive than we had so far. First, I just wanted to show you like what the heck I was talking about. Okay, so I had learning goals. I know from talking to people as a biochemist what you know and what you don't know about cells. I know the moment your eyeballs like hit the back of your brain. People are like, what were you doing in the lab? Why are you late for dinner? I'm like, well, I was trying to purify a protein. And the idea that you could, isolate one protein, like what? Like, why would you want just one protein? Why don't you just get this bucket of protein powder and come to dinner on time? So I knew I wanted to show people that the cells are crowded. The surface of a cell is complicated, that there's action, really important stuff happening there. And so that's why I designed the game this way. But then, how do I know you're learning that? Right? Everyone knows we need to do testing, but what do you test for? How do I know people are enjoying this? Do I wait for them to say, yes, I liked it? They can see me standing there. They're going to tell me they liked it. So how do you know a game is fun? There's no measure that is like, this is definitely fun. So how to test your game is very super important. At first you need to know what you're looking for and then define that and then make it, okay? And so basically you've walked in to talk about science. You are doing science. As the game designers, as the user experience researcher, you're doing science. You're doing psychology. You're doing user experience research. Okay, so that's what we're gonna talk about. Awesome. Okay, so I want to know from you guys what you know. Who's made a game with more than one person? Awesome. I know you're a student, made a game. Who in here is a student working on a game with other people? Just one? From West Virginia?
Yeah.
Awesome. That's cool. Okay, who's made a game and published it on itch or something with more than one person? Awesome. And finished it? Yeah. There's fewer hands went up for who finished it, right? Okay, all right, good. Awesome. Because the hardest part is finishing it. The schedule. You need time to finish it. Okay, good. Yeah, and the game I showed you, it's still a prototype. Immune defense, still a prototype. All right. I'm thinking, where was I going? Okay. Made it with multiple people. Did you have a design doc? What kind of design docs have you made? Anybody?
I normally do a game design document, and then I treat it very much like a software application. So I do a scope plan for first iteration, second iteration, and third. Generally, my MVP, my desirable, and my wish list items.
All right. So you have a list of tasks that you think you're going to need to make. In which ones?
I just divide my my GDD and that kind of stuff. So my game design document is generally separated into like an MVP, a desirable, and like my wish I could have these features. And
Okay. So then, in a typical game design document, you've got like words, like descriptions of like the aliens will be really big, and the good guys are real small, right? Is that what you got in your game design? What do you got in your game design?
I usually cater to the 3 Cs: characters, cameras, general controls, and then besides that, like a little bit of style and direction that I'm kind of going for. It depends how fleshed out I have that idea first, but generally want to start at least with my 5 big pieces that I want to
Yeah,
accomplish.
and you have like 5 pages of game design doc.
It depends which game.
Okay, okay. Anybody got something different? Yeah.
For smaller scope stuff, what we usually do is we take the team, or I take the team that I'm working with, and we just kind of go into like a collaborative like drawing space,
Uh-huh.
and we mostly just we kind of put down ideas, we cross some out, we kind of iterate like that. We do little drawings. We try to keep it like pretty open ended for smaller scope, and then because we know like let's say it's like a 7-day game jam, like.
Oh,
our-
game jam. Oh yeah, game jam's
Yeah.
way different.
Well, or like if
Yeah.
you have even a constraint, like a 1-month constraint, like your first guess as to what the game is going to look like is probably going to be just as good as just like making
Yes.
something and then iterating on it.
Yeah, that's the thing
Yeah.
with game jams. Yeah, game jam, all bets
But
are off.
For like larger scope, I kind of just have like a giant like Obsidian database that I just spit stuff into, and then I work with it as needed. I've had only a little bit of success doing like preliminary documents for larger scope projects.
Mhm. Okay.
Yeah.
Yeah, I'm not here to say you're not doing it right, by the way.
And
Like,
I think it
Yes.
depends on what kind of thing you're working on. Like,
it
there's
does,
very
absolutely
different
does,
types of
absolutely
games.
does,
Yeah.
absolutely does.
I think it also has to do with your background. Like,
Yeah.
I come from a systems engineering background, so I'm always thinking like MDSC kind of stuff, and like I need to know what my systems are going to look like because
Yeah.
I'm very detail oriented in that
Yeah.
manner. So for me, that might not necessarily work, but we do that for our pitch nights. That sounds like somewhat what we do for our pitch nights. So.
Okay. Anybody made a game macro? Do we know what a game macro is? Yeah? Yeah?
I used to make macros just like to get through games quicker as like a kid. Like, do you mean like a macro in the sense of like playing a
Automatic.
game, like automatically playing a game? Or
No,
do you mean a
I
macro?
don't, but that is really good. Yeah, I mean something else.
So I did it for wargaming for the government. Like basically, we do macro games specifically for like if we're like simulating stuff. It's
A
more-
macro game?
Yeah, a macro game.
What is a macro game?
For in the context of where I've worked on,
Yep.
has been small scale like variants of specific situations that we're modeling.
Small scale variants of the situation?
Yeah, like
Macro.
campaign level stuff.
Okay, so you're like bird's eye
So,
view of a
We might have
war.
six different like types of wars that are happening. So-
Okay, awesome. So 2 other definitions of macro I wasn't even thinking. Everyone's done a macro in like Microsoft Word or in your game. So if I hit this button, I want you to do Control-Alt-C, this and that and the other thing. That's brilliant. And a macro would be like a big strategy game. Okay, awesome. And so yeah, game jams. I love game jams. Everyone loves them because they're so freeing. They're like, oh, if I wear this hat and take this picture, it'll look just like a, knight with my feather on the back.
I think they're so stressful. I do them mostly to mentor people. Like if I have someone I want to bring into our team.
Why are they stressful?
I don't like working with a heavy time constraint. Nobody
Why?
really does.
Uh-huh.
But like for me, I know that the end product isn't going to look the way I want it to.
Because you don't have time to make it as pretty as you want.
Yeah, no matter how perfectly you execute the planning, it's always going to be falling short in some capacity.
Yeah, I feel like everything will do that. Okay, so what I want to talk about today, and the reason I've got anything to talk about is because people make bigger games, and then also people work with other people. So like your artist doesn't need to know what system you're making in C# or C++. Artist needs to know what's my definition of success for this 3-dimensional model I'm making. Some things are basic, like is the player going to be able to see like the chin? Can I just make a flat one polygon right here, or do I need to like curve the neck, right? Is the player going to be able to see how close is the player going to get to this model that I'm making? That's kind of a technical thing. But when you start making, start thinking about the lore, oh, well now, do I need the feather for the French knight? Or is it going to be like one of those big helmets holding my nose. Like, now you've got lore, and your definition of success is different.
So you're talking about like writing up like maybe a world building document before
No,
you start.
I'm not.
No.
I'm not talking about that, yeah.
Are you talking about metrics of success? Like
Uh-huh.
your benchmarks?
All right. We're getting there. What I was hoping to get just is an assessment of what you guys know and think about, and then we're gonna start talking about it. Okay, so we're ready now to do the talk. Excellent, this is good. This is how I operate. I have a raging case of ADD, and as I've gotten older, my ability to control my ADD has gotten weaker and weaker. So you're getting full on, this is my brain.
Do you want the lights off again?
I don't think so. I don't have pretty pictures. I'm trying to hit this. Oh. No, it's not. I'm trying to hit this little show me a slideshow thing. It just won't work. Why won't it do the slideshow? What have I done wrong in my life to deserve this? Okay. You know, yeah, we're gonna have to turn off the lights. This is remarkably dark. And I don't know what I've done wrong in my. Okay, yeah, we're gonna have to turn off the lights because y'all can't see it. Everybody hang tight. We're gonna be in the dark. And there's some light behind us. Okay. Can you see this?
Yes.
Yeah. Okay. Come on in. We're just getting started. Well, we've been chatting. All right. So the title, do you guys have something you want to tell me about? Because I'm down for telling me stuff. Or are you planning your next game?
Oh no, we're just waiting. Sorry.
No. Yeah, sorry. Okay. All right. So today was a talk. We're playing a Cerny method of games about reality, and like I already told you, involving a subject matter is like involving an artist or involving another coder. You need to bring them on and keep up with what everybody's doing. Okay. And so, prototyping a science game is another title for this talk. Making a game about something you personally don't understand is another title for this talk. Like, if you're not the Star Wars expert and you're making a Star Wars game, so you might be one person who wants to make a game about, chicory flowers, and you need a chicory flower expert. It's also just making a game with other people, like we talked about. Okay. The problem with other people is you need a schedule, and likely you need a budget. So your chicory expert is like, I'm $100 an hour, tell you all you need to know about flowers. Well, now you need to know what you want from them before you get them, so that, okay. All right. So the simple answer to all of this is you want your expert with you from the beginning. When you start imagining what your mechanic is going to be, that's when you want all your best people there doing the ideation. Okay? So today we're going to talk about words that people who are wiser than me have come up with. I do not know what I've done wrong in life. I thought this was going to work so much nicer. Okay. So Mark Cerny, this tiny little thing you can barely see here. Mark Cerny gave a talk in 2002 at DICE. DICE is a conference that is really amazing. So in 2002, he gave a lecture to a bunch of game developers, and he said, we need to talk about process. We need to talk about how we make games. We could be doing it better. And his simple idea was that games, the ideation could be separated from the production. Okay. Another person I want you to know, I picked out a couple of people from this list. I'm going to give you these slides, by the way. You'll be able to get them. Is Amy Hennig. Have you guys played Uncharted, for example? Okay, play Uncharted, get yourself a PlayStation. Amy Hennig was the writer and director for a whole series of games, and that's her here. And this is her IMDb page. So she was the force at Naughty Dog that inspired them and directed them into making these movie-like video games. So when you play Uncharted and your friends are watching, it feels like they're watching a movie. Like you feel like you're in the movie, you're in this story. There's a lot of interactions between the characters. You get to interact with people that you have these conversations with. You feel like you're doing a heist with people you care about. It's really a neat experience. And as you know from video games, story is sometimes the last thing that gets taken care of because so much else, right? The coding, the art, and the gameplay. So if you're going to make a really good story, you're going to need a really good production process. And so Amy Hennig is this inspiration for creating such a great process. Okay, so this process came from Mark Cerny. This link, I'll give you the slides, will take you to the DICE talk in 2002. And then in 2014, he's being interviewed about his talk and the effect it's had on the industry and everything. And this is a great talk over here about him talking about anxiety. He's very anxious. Talking in public is not his favorite thing to do, but thank God he did it. So, Cerny method, the first thing about it is it divides pre-production and production, divides them into separate things. And the other big idea is that pre-production is creating a prototype, playing around, seeing if you like it, ditching it if you want, and starting over. And so it's an unknowable amount of time. It cannot be scheduled, which is a really crazy thing to tell people at PlayStation and, oh, we want all your best people on the project. We want the best artist, the best programmer, best game designer, and then we want to pay for some subject matter experts to be in the room with us, or lore experts, whatever you're making, and we don't know how long it's going to take. That was Mark Cerny's first main point. The second main point is our definition of success getting out of that room is that we've made a prototype, we played it, we love it, we play tested it with our target audience, they love it. And then you make a vertical slice that is a first playable that's production quality, like really good. And then what you've got there is something that's going to complement your game design document. The artist will be like, well, this is the art style, it's in the slice. This is the mechanic, it's in the slice. And so coming out with a first playable is a very important part of the process. There's macro and micro design. This is where the term macro design came from, a macro chart. We're going to go through that. In gameplay testing, we're going to go through that. All right, so this is Mark Cerny. So after Mark Cerny, this guy, Richard Lamarchand, picked up the mantle, and he was also at Naughty Dog. So I know Richard, he's amazing. He's now at University of Southern California in the game program that Tracy Fullerton leads. And he comes to conferences. He comes to a bunch of learning game conferences, actually, and he's a really great person to hang out with. In my head canon, Amy Hennig was like, I have a vision for this awesome, story-driven, really great, well-written game. And Richard Lamarchand said, yes, we can make this production happen. So he worked with a bunch of people, and he thanks them in this. This is from an interview. There's a link at the bottom. From an interview, it's really great to read, but he thanks this whole crew and everybody. And he's standing on Mark Cerny's shoulders. And what Richard Lamarchand did, after he got to be a professor at University of Southern California, Tracy hired him up. He wrote this book. So everything I say today is much more what better said in there. He's not talking about science games, and he's not talking exactly about making these really novel mechanics. I'm going to talk a little bit about that. But Richard made this brilliant book that really well explains how to make a game macro, how to ideate, how to make that pre-production time very productive, and what exactly you need to come out of in your hands, that first playable game, the game macro that's going to describe everything you need to make, and a schedule. And if you have that in hand, you've got a production plan. You know when to bring in your expert. You know when you're going to need the software. Anyway, it's fantastic. You get this book, A Playful Production Process for game developers and everyone. So it doesn't really matter what you're making. If it's a big, complicated thing, we need to organize people. It's good. Okay. All right. So any questions? We're kind of done with that. Yeah.
Could you apply like that principle that I forget the guy's name?
Mark Cerny?
Yeah,
Rich-
right, yeah, the
Cerny method? Yeah.
the Cerny method.
Uh-huh.
Can you apply that like from like a sprint to sprint, like week to week, like progress standpoint, as well as the overarching project?
That's a really great question. That's a really great question. So the question is, can you do it every week to week in an agile sprint sort of manner? Can you think, what do I need to make and iterate? And I will say yes. In fact, you need to do that.
Yeah.
You definitely need to do that. And I didn't put it in the talk because I didn't really want to just explode your brains. But you do. You come up with your idea, and you need to keep building it. You need to keep thinking of the idea. So let's skip to this for a minute. This is my idea of ideation. These are little yellow squiggles. So you do some ideation, and it goes into your mechanic. You do some blue sky thinking, goes into your mechanic. Creating a toy, we'll talk about that in a sec. Think of like, this game is going to be like an epic adventure, and there'll be 8 different tools you can have. Think of like a simple mechanic as a toy. Think like a child, like, oh, I have this random thing, what can I do with it? Blah, blah, blah. So you do all this ideation and blue sky thinking, and like, if I could have anything I wanted, if I didn't have to do any software development, would I want to do grappling from the moon? Whatever. And then you create your mechanic from that. That's where you're flying on the surface of a cell, and things like that. And then you start building it and testing it, and finding out if you like it. In this loop, you are going to go through this loop after pre-production is over. You're gonna make the first playable for real, the proper non-vertical slice, but the real thing, and then you're gonna test it, and something will happen. You know, your players will be like, "Oh, awesome! I'm grappling from the moon," and you'll be like, "No, it's not the moon; it's trees. They're all getting the wrong idea. We need to change it so that they get the right idea." And that is why you're going to keep doing loops even though you're in production. Any more questions before I go back and like try to go through properly? No? Nope. Okay. This is from the book. Can you read this? It's really not very well lit. We only got a little more time. Okay. So here's ideation and pre-production. That's what we've been talking about. Ideation. Blue sky thinking, all is great. My take-home message for you is, if you want to make a game about something, you need the scientist, the lore expert, you need everybody in the room, okay? You don't hire your 3D artist after you've decided what's gonna be in the game, okay? So we're all indie, we're like begging people to work with us, we've got no money, but everybody's got a different realm of knowledge. So the 3D artist has tricks up their sleeve that you don't know. They've got a perspective that you don't know. They have experience that you don't know. And if they're not in the room when you're making these decisions, you won't know them either. All right? It sounds kind of dumb, right? It sounds like, well, yeah, that would be great. But it's profound, the difference that it can have. And then you bring in these experts, like maybe you want to make a game about cells or birds, and you need them to be there as well, okay? And then my other take-home message from this whole talk is you've got your experts, you've got your artists, you've got your programmer, scientists, we're all in a room together. The scientist is going to say, I want to have a whole bunch of proteins bouncing around, and I want the player to be able to see them all bouncing, right? And the software developer already is like, oh my God, that's so many colliders, we're never going to be able to do that. The artist is thinking like, how am I going to draw them? All right, and so what's happened? I had an idea, and we've moved away from the idea. We've moved into what ifs and problems. But we need those problems, right? We need the what ifs and we need the details. So what I'm encouraging you to do, and this part's not in the book, all right? This is what you get from being right here with me, with a scientist that has made games before. What you need to do is record this stuff, get the idea, say it, and then be really formal in how you discuss with each other. You need to hold your idea, oh my God, how many colliders? Oh my God, how am I going to draw that? And what I suggest, and what has worked for me, is you go in a ring around the room. You've got all these people with this giant Venn diagram of stuff they know, and the rings don't overlap. You've got like 5 rings of knowledge not overlapping, and so what happens is I say, I want a whole bunch of proteins in the scene, bouncing around off of each other. And then the programmer will say something like, really, you want 500 colliders that's going to run on a phone? And then somebody else will say, you know, how many polygons is each one supposed to have? And then you come back around. Now, you got to go around a couple of times. And then the scientist can say, oh, I didn't know that having a whole lot of colliders was a big deal. And I don't even know what a polygon was. I was that scientist in 2009. And then I can say, well, I want the user experience to be having this feeling that there are many things bouncing around off of each other. Because I have this idea that I want people to understand what is Brownian motion. It's not that the proteins know where they're going, that they're actually colliding with other things. I want them to have that feeling that they're colliding with other things. And then, now the software developer and the artist and the game designer can answer me and say like, oh, we want to create that user experience. We want to make that, how could I solve that problem without 500 colliders? You see what I'm saying? So it's a sit-in. It's a moment that you need to plan for. You need to say, okay, we're in pre-production. It's going to start at 10:30, so get your coffee at 10. We've got an hour and a half of fresh brainage before our brains check out. And we've got a list of learning objectives. The scientists came, or you've got a list of like goals you want for your game, whatever it is, you got a list, and you're going to go through them, go around and brainstorm, write them all down. But then you have to go around because you're going to make assumptions about what somebody meant. And if you don't go around and clarify, and go around 3 or 4 times for every idea and get all that input out of all those people. Okay. All right, my mind is more settled. I've said the important thing. Okay, so the other important thing, this is not the best chart, but we're going to go with it. I've got a prettier one, but I'm not going to try to pull it up. Okay, the important thing is you make a prototype, and how do you know it's working? You have to test it. And everybody knows you have to test, right? Who do you play test with?
Your target.
What?
Your specific target.
Your target, exactly. Your target audience. If you're going to make a first-person shooter, do you play test it with me? I get seasick scrolling on my phone. You don't want to play test with me. You want to play test with other people who play first-person shooters. Exactly. You need to find your target audience and play test with them. And then what do you look for? What kind of data, you've got 5 people working on the game. How do you know they're doing the right thing? It's an extremely good question. Okay, awesome. What else? How many people do you need to play test with? There are papers written on this, research papers, huge numbers of research papers. How many people do you need to test your game? And I think 9 is one of the answers. You need 9 people to find all the bugs.
9.
Yeah. There's a Microsoft paper that comes up, 9. So what you do is you see people finding bugs, but then the 9th person doesn't find any new bugs. It doesn't find any new confusion. And so, yeah. Okay, so here. Yeah?
One note on like playtesting quantity, there's something to be said about when you're refining the accessibility of your game, that you do want to playtest with a wider group.
Yeah.
So that you can have like, for example, like colorblind people.
Exactly. It's really true. If you want to see, maybe strategy players might like my game. Well, then now you play test with some strategy players. You just need to know they're strategy players. You want to play test with low vision, then you find me and you ask me to play your game. Exactly. If you want to know data, you have to do the right experiment. You can't say like, oh, well, 10,000 first-person shooters love it, so I'm sure it's going to be popular with everyone. Nah, you will get kicked out of your PhD program for that. That is not logical thinking. You want to know that people with extreme nearsightedness are going to like your game. You got to find extreme nearsighted and get them to play it. Yeah, you want to know that people who play Plants vs. Zombies are going to play your first-person shooter just because it's got zombies in it. You gotta prove that data, yes. And so, how to know? And this is all wrapped up in what is a game macro. Okay, so a game macro is a plan for what needs to get done in order to make everything happen. And you can't see it, so I made this nifty slide here. This is the heart and soul of your game macro. Okay. Highly recommend getting Richard Lamarchand's book and reading it. There's something called a player goal. And then there's something called a design goal and emotional beat of the story. Okay, so design goals, you're familiar with design goals. In my platformer game, the player needs to find the gold toilet or they can't get to the next level. Right? You're familiar with this. Like if they don't find the bow and arrow, they can't go on into the dungeon. That's a Zelda thing, right? Or, okay, so that's your design goal. That's you thinking, what do I need the player to manage in this moment? The player goal is a really neat concept. What does the player think they're doing? What does the player want to do? What's the player's goal right now in this instant? And it's changing constantly. It's getting data from you in the game. It's getting like, I can see things in a distance in the distant environment, and I'm like, oh, is that something I'm supposed to go for? I can see things right at my feet if I look down here. I'm getting constant information about what I could do. And you're always thinking, what's the right thing? What am I supposed to be doing? You're also thinking, what might be fun? What would I like to do? What do I want to do? Okay, and so you need to be thinking, what is your player trying to do right now all the time? And that's your grounding truth, for want of a better word. You're always thinking, what do they want to do? And so in the game macro, I know it's hard to see, but you've got your player experience, player goal right there, and you've got things on the left side here that are details. This is stuff that you write in your design doc, but here now, it's purposed. So if you want your player to think they need to go to Guadalupe, you put stuff in the game that lets them know that's what they're gonna want to do. And sometimes it's the environmental art. Sometimes it's the mechanic that's available. This is all what you've got in the game, and then on the right side, for the way they've organized the game macro at Naughty Dog, you've got assets. These are the assets in the game that provided those things for the player. Okay, so they feel like they're in a certain place because of these assets that you made. Okay, and so what the game macro does is it takes that takes the 5 pages of game design and makes it very lined up so that you know this is why you're making it. So this first column is the level name or the location. Uncharted is a very big game. It's got many different locations. We all know we start here and we go to these other places. But you might be making a level game that's got different levels. So you might this might be a sequence, level 1, level 2, level 3. And also, this is the macro. You're going to have a little level description probably for every level. What happens at the very beginning of the level? What happens in the middle and in the end? And you're always tracking, what does my player want to do? What is my player trying to do at this moment? Okay? Any questions? It's very interesting at this point. What's on your mind?
So like with this macro, the structure of the macro like vary per project, or is this like something that
Yes.
Naughty Dog uses?
The structure of a macro varies by project. Richard Lamar makes that very clear in the book, and you will too. So you don't need weather. You might need mood. My game, in defense, I don't have mood at all. You don't need it at all. You might not need a brief description, whatever. Yeah, you could change this. Absolutely.
And
Yeah.
could you do like a macro for like a specific aspect of a game instead of the whole game?
Yes, absolutely. So just to give you a sense of scale, when they made the macro for Uncharted 2, I believe it was, they were in the office, like 5 or 8 people, for 8 months. Yeah, it was a very large macro. And you might guess, like just because I put up here that we're here, we're doing this at this moment, there's details behind that macro. Yeah, absolutely. When you get down to it,
So do you have people whose like entire job is managing one of these for something of the scope of what Naughty Dog would be making?
Yes,
Really?
yes,
Wow.
yeah. There are producers. Oftentimes, the game designer becomes a producer, which is why Richard Lamarchand is the lead designer and also became the person who wrote the book on how to produce a game. Yeah, so a lot of times people think of a game designer not as, I am the person that knows how to make the coolest game. They are the person that knows how to preserve the vision. How to say, if we want to make a game that gets the player to Guadalupe by level 3, we're going to need to build these assets. And that, you're right, that's the glue. That's how to make it all happen. Right? Oh, question in the back.
Yeah, on the topic of production, where does budget and funding kind of fall into the game macro?
Yeah, that's a very good question. And I'm not going to cover it today.
Okay.
But when you're done with pre-production, you've got 3 deliverables. You've got that 5-page description of the game, aliens big, humans small, steampunk style, and then you've got this macro. And then you have a schedule. And the schedule is when you start talking about person hours, how much those people cost, how much you need to make. And the glory of the macro is you know why you're making things. And this is why I talked about the definition of success, right? So I'm trying to make the schedule, and this is why you need to do all of it before the end of pre-production, because you can't say you have a schedule until you know all the things you need to make. And let's say we're hiring our 3D artist here. On the paragraph description of the game, the 5-page description, I'm like, oh, there's dragon sculptures everywhere. It's glorious. And in the player goal, I know I want the player to go try to, I don't know what they're trying to do. They're trying to get to a place. We're trying to get them to a place. I want the player to think, I want to go to this place. Well, Do I need 20 dragons for that? Do I need 20 new dragon sculptures for that? No. I might, need one dragon sculpture and then make it different colors. So the point is, I can schedule the time to make the dragons because I know what they're useful for. I know what they're going to be used for. And if I don't have a macro that tells me why I'm using that asset, I don't know the definition of success of that asset. And so, yeah, this is how you manage cost and make sure the process is going to work, but also so that you know what you're going to get what you need to make the game. There was something that crossed my mind. I realized I didn't say. One more thing that was really important is the idea that what makes the game addictive is that you, the player, are creating for your own self, your own goal. Csikszentmihalyi is the guy that developed the word flow. You know the word flow? Everybody knows that one, right? Flow is that state where you're being challenged, but not too much. You know you can figure this out if you just give it 30 seconds and try to figure it out, maybe a minute. Maybe some people really like big challenges. And that's the state of flow. Mihaly studied happiness, what makes humans happy. And he realized that people who were happy were working hard at something. And he also invented a term that I don't know how to pronounce, but it's like autolism, auto, and it's when I am making my own goals. I am doing this hard thing, and I'm making my own goal. I want to make that tree. You study people who paint. I want to make that tree happy. So that's my goal. That's why I'm motivated. And what we do as game designers is create this space, this system to let people create their own goals and find answers. We need to make sure we've created the assets to give them the goal. We've got a design goal. They're gonna do 5 things, but then they're gonna have to do our design goal. And our whole job is to make them feel like it's their own idea. And you need to limit the possibilities. That's a whole nother how to make this happen. We're not gonna get there, but you need to make sure that you've made the things to give them the opportunity to make the goal. Okay. Real quick. This is also me. This is me as a scientist. How does your user make this decision what they want to do next? So when you're making a game about cells and proteins, or you're making a game about aliens, there's a whole bunch of new stuff on the screen. People are like, what am I supposed to do? Am I supposed to kill him? Am I supposed to introduce myself? If you want to make something really unique, if you want to make a game where you wave your hands and people's windows open up and close on the building, right? Something really crazy weird. If you really want to innovate, you've got to guide your users into how to do it. So then you've got to think, what are they doing? What is that user goal they've got in their head? How are they thinking? Well, I'm here to tell you, you're all scientists, and the joy in this world is being a scientist. You are always gathering data, making a guess, you're doing an experiment, and you're getting feedback. And it spells games, like G-M-E-S. It's the games method. Okay, so anyway, this is what people do. You walk past this building, and there's something weird about it. You notice something, and you're like, there's a sensor. When I wave my hands, something happens. And then you're like, I wonder if I wave my hands bigger, will something bigger happens? And if I don't see feedback, what am I going to do? I'm going to stop waving my hands around like an idiot on the street, right? And so I got some feedback. Didn't happen. But if you want me to wave my hands bigger, what do you got to do?
Make something happen.
Yeah, you got to make something happen that I notice. Okay, this is what your people are doing. This is what is in the user's mind. And this is what you need to test for, right? We all test, and we all say, they didn't wave their hands. You're human, so I know your first response is, that person was stupid. they should have just kept waving their hands. We all blame the user right away. Okay, you gotta, again, do some formal thinking and say, okay, force yourself to go through this. Force yourself to think from the user's perspective, and this really lovely chart is what you need to pick up, because forcing yourself to think formally is hard. Making a chart is useful. So this is my version of what's inside that user goal column. This is my version of what's inside of there. Your user is going to see stuff. What do they see? They're going to make a guess. It's in their mind. Their mind is making a guess. That's their goal now. Their goal becomes, I think if I click on that cell, I'll get some information about it. And so then they're going to do the thing. They're going to do the experiment. Click on the cell and get feedback. When they click on my cells, nothing happens. Nothing happens. Silence is something, like a really good lack of information is actually kind of useful. Then they're going to think, maybe I can click on those purple floaty things. And when they click on it, they make the guess, da-da-da. It makes the sound. And then they're like, ah. Because in my game, everybody thinks they can drag the cells around, but you can't. You have to get the cell to move itself. Totally new concept. Everybody's completely baffled by it. What the hell is going on? So what I had to do was make it very simple so that this loop only took like 3 or 4 loops through before they did what I wanted them to do. So I needed to get their user goal to be my design goal. And what I had to do to make that work was take out all kinds of stuff that I thought was great, but it was confusing them, and they weren't getting through it fast enough. So they would make a guess, try to do a thing, and they do this loop a lot. But if you go through this loop for a minute or 2 minutes, you will stop playing with the game and smile politely at whoever gave it to you. So I realized if there were like 2 things that were interactable, they would go through this loop about 4 times. They'd say, maybe I can click on that, nothing. Maybe I click on that, nothing. Maybe I'll click on that, something happened. And then you're in it. Now you're like, I love experimenting and getting feedback. Everybody loves it. Okay, and so then when you're testing, I'm almost done. When you're testing, this is what you look for. Did they see the feedback? And you can do that by watching them. You can do it by quantitative. There's many ways to test. Okay, all right, so that's it, you guys. You've been a wonderful audience. Misconceptions very important. You'll see my slides. Hit the lights. Thank you.